Hi guys, so today is our last day of new content, and really today is going to help us review something that we did earlier this year, which was solving quadratic inequalities. So what we're going to do today is we're going to look at polynomial inequalities, and the process really is very similar. The only thing that's going to be different is you're going to have more than two roots potentially, so we need to consider all of our roots and also consider on those or equal to, make sure we know which ones are our zeros. All right, so what we'll do first is just review a quadratic inequality. So if you remember, the first thing we did was we found our zeros. In this case, this one's easiest to factor. So my zeros are -2 and 6. And what I did was I marked those on a number line. Then we did something called a sign chart. Remember, SIGN sign chart, not like sine, cosine, sine. And we filled in where this graph was positive and negative. And we did that by picking test points. So I picked some test point in this region, like 0 in this case. Whoops, that should be a -2, sorry. So some point in that test region would be like a -5. If I plug in a -5 for both of these x's, -5 minus 6 would give me a negative number, and -5 plus 2 would also give me a negative number. A negative times a negative overall is positive, which means that everything in this test region, everything over here, is going to be a positive number. Then I moved into the middle test region. So something in that middle region would be like 0. Okay, 0 minus 6 is a negative. 0 plus 2 is a positive. And a negative times a positive is going to be negative. So everything in that middle region is negative. And then everything to the right, okay, any number greater than 6, if I picked 1,000, 1,000 minus 6 is positive, 1,000 plus 2 is positive, and a positive times a positive is always a positive. Once that sign chart was filled in, we used it to answer our question. We want to know when that function was less than or equal to 0. In this case, that is the negative region. Since it's or equal to, we do include those endpoints. So this is negative from -2 to 6 with brackets. All right, so with polynomial inequalities, it's really the same thing. The only thing we need to do is factor if it's not already factored. So keep in mind, if you can't factor the normal way, you may need to factor using that rational root theorem. But again, the goal here really is just to find your zeros. So I need to start by setting this equal to 0. So I'm going to subtract that 5x, and now I can factor. So in this case, I can take out a GCF. Then I can factor that remaining polynomial. So that's going to be x plus 2, x minus 1. And now I can find my zeros. So my zeros are 0, -2, and 1. And now we fill in our sign chart. So again, I can pick test points. So anything in this region, like a -10. Okay, if I plug in that -10, -10, -10 plus 2, and -10 minus 1 are all multiplied together. So that would be a negative times -10 plus 2 is a negative, -10 minus 1 is a negative, and a negative times a negative times a negative overall is going to be negative. So everything in this region is negative. All right, picking something in this region, like a -1. -1 would be negative, -1 plus 2 would be positive, -1 minus 1 would be negative, negative times negative overall is positive. Pick the next region, something between 0 and 1, like a half. Okay, 1/2 would be positive, 1/2 plus 2 is positive, and 1/2 minus 1 is negative. Positive times negative, overall is negative. Then last region, anything greater than 1. Okay, that's going to be positive times positive, which overall is positive. Once our chart's filled in, we answer our question. We want to know where this function is greater than 0. So we're looking for the positive regions. So I have one here, and I have one here. So in interval notation, this would be parentheses. So -2 to 0, and 1 to infinity. So again, very similar to what we did with quadratic inequalities. You're just going to have a few more zeros. The other thing that you can do here is you can think about the graph. Okay, so if that's easier for you than picking all these test points, let's think about what the graph of this function would look like. So I'm going to erase my chart. And let me rewrite it. So here's my zeros, -2, 0, and 1. We know that this is a positive leading coefficient and an odd degree, which means I know my ends are going to be like this. I know all those zeros have multiplicities of 1s, so I know my graph is going to cross, cross, and cross. Well, if that's the case, then I can clearly see where this graph is positive are those regions that I marked. So you can also use what you know about the graph if that's easier for you to be able to answer these questions. All right, let's try this next one. Again, we have to set this equal to 0 first. So x cubed minus 2x squared minus x plus 2. Let's go ahead and factor. This one we're going to factor by grouping. So I get x squared minus 1 and x minus 2. X squared minus 1 factors into x plus 1 and x minus 1. Which means, again, I have 3 zeros, -1, 1, and 2. So in order to fill in my sign chart, I can either pick test points, or again, I can think about the graph. All right, thinking about the graph, this is an odd degree and a positive leading coefficient. That means my ends are going to look like this. So I'm going to be positive over here and negative down here. All of those zeros have a multiplicity of 1, so all those are going to be cross, cross, cross. So I can now use this to answer my question. Where is this less than or equal to 0? So where this graph is negative. All right, so again, this would be brackets because it's or equal to. Whoops, but not a bracket on infinity. And that would be my solution. Again, if you want to pick test points, you are welcome to do that as well. A little bit different process. We're going to get the same answer. So -1, 1, and 2. Okay, so picking something over here, -10. -10 plus 1 is a negative. -10 minus 1 is a negative. -10 minus 2 is a negative. Negative times negative times negative overall is negative. All right, in between would be 0. 0 plus 1 is positive. 0 minus 1 is negative. 0 minus 2 is negative. Positive times negative is positive. In between 1 and 2, 1.5. 1.5 plus 1 is positive. 1.5 minus 1 is positive. 1.5 minus 2 is negative. Positive times negative, overall negative. And finally, greater than 2, okay, that's going to be positive, positive, positive. So again, we still get the same solution. We're just doing it algebraically as opposed to graphically. All right, let's look at these last two. Now, these two are already factored for us. So again, we can either consider what we know about the graphs, or we can pick test points. So let's do this first one with test points. Okay, I'm going to start by marking my zeros. So I've got -4, -1, and 5. So let's pick a number in this first test region, everything to the left of -4. So -10. So this out here is being multiplied. So that is automatically a negative. And let me go ahead and write this out. Here we go. So let's use -10. That's going to be a negative. -10 plus 1 is negative. -10 minus 5 is a negative, but a negative squared is positive. And then -10 plus 4 is negative. So again, we're going to do a negative times a positive times a negative. Sorry guys, that's squared. So that's positive. Sorry about that. So I've got a negative times a positive times a positive. So that overall is going to be positive. All right, let's pick that next test point, something in between -4 and -1. All right, so let's try a -2. All right, so if I pick -2, I still have this negative. -2 plus 1 is a negative. -2 minus 5 is going to be a negative. A negative squared, though, is positive. And then -2 plus 4 is going to be a positive, and a positive squared is still positive. So that gives me a positive in that region. All right, let's go to the next one. Something in between -1 and 5, like 0. Okay, I still have that -2. 0 plus 1 is positive. 0 minus 5 is negative, but a negative squared is positive. And 0 plus 4 is a positive. Negative times positive, 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 overall is negative. And then finally, that last test region. All right, anything greater than 5, let's say 7. I still have that negative on the outside. 7 plus 1 is positive. 7 minus 5 squared is positive. 7 plus 4 squared is positive. So that's going to give me a negative, positive, 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 which is overall negative. So we'll use this to answer our question. We want to know when this is less than or equal to 0. So we're looking for the negative regions. So I've got this section right here and this section right here. Since it's or equal to, we can include this point. So we could say from -1 to infinity, because 5 is included because it is a 0. But we also have to consider the other 0 that's not really in that negative region. -4 is a place where that or equal to is true. So we're actually going to have -4 and that region right there. All right, let's try this one again, except this time instead of algebraically, let's try it graphically. So I'm going to draw that same chart. And I think you guys will see it's a little bit easier to do this one graphically, which is why it's really good to know our end behavior and what our graphs do at our intercepts. All right, so let's look at our degree. So this one's in intercept form, so I got to add them up. So 2 plus 2 plus 1. There are no x's out here, so that does not affect our our overall degree. So this is a degree 5 polynomial. So this is an odd degree. We do have a negative leading coefficient, which means my ends are going to be here and here. We do have some squared factors, which means at those points my graph is going to touch. So at -4, my graph would touch. At -1, my graph would cross. At 5, my graph would touch. And now I can look at this graph to answer my question. So less than or equal to, I can tell it's this region here. And again, I do need to include that x-intercept because it's or equal to. All right, try this last one on your own if you feel comfortable. Otherwise, we'll work it out together. All right, so we'll go ahead and do this one. We'll try this one graphically first. So let's mark our zeros. So I've got 0. X squared plus 9 is not going to give me any zeros, any x-intercepts, because x squared plus 9 is going to give us imaginary zeros. Those do not affect the x-intercepts of our graph. Okay, well, those imaginary values, that plus and minus 3i, algebraically would give us 0. It's not going to be an x-intercept, so it's not going to affect where our graph is positive and negative. I also have -2 and 5. All right, let's look at the overall degree here. So I've got 1, 2, 3, 4, 5. So this is also a 5th degree polynomial. This time I have a positive leading coefficient. So positive and odd degree. And then -2 has a multiplicity of 1, -5 has a multiplicity of 1, and 2x has a multiplicity of 1. So all of these are going to be cross, cross, cross. X squared plus 9, even though it's in there, again, it's not going to affect our x-intercepts. So this graph, we're trying to find where it is negative, which leaves me with those regions, -infinity to -2, and 0 to 5. Now again, if we're not sure graphically what's going to happen here, we can always pick test points and use our sign chart. So I'm going to try this one more time, and we'll try this one algebraically now. All right, so let's make our sign chart. There's -2, 0, and 5. And let's pick some test points. We'll start with that first region. Let's start with a -3. So 2 times -3 is negative. -3 squared plus 9 is going to be a positive. -3 minus 5 is going to be a negative. And -3 plus 2 is going to be a negative. Negative times positive times negative overall is negative. Next test region. All right, let's try -1. -1 times 2 is a negative. -1 squared plus 9 is positive. -1 minus 5 is a negative. -1 plus 2 is positive. Negative times positive times positive overall is positive. Next region, something like 2. 2 times 2, positive. 2 squared plus 9, positive. 2 minus 5 is negative. 2 plus 2 is positive. Overall, that makes that region negative. Last test point, let's do 1,000. That's going to be positive, 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 positive. So that whole region is positive. We get the same chart. We're still looking for the negatives, and we get the same solution. So again, it's up to you graphically or algebraically, whichever one you feel is easier. Maybe you can start with one and just check it using the other option. But that's really it today. Today, really, it's a good way to kind of reinforce what you guys know about those graphs and also reinforce what we did earlier this year when we were talking about quadratic inequalities.